All right, let's jump right into our topic today, schizophrenia. We're going to be using Dr. E. Fuller Torrey's incredible book, Surviving Schizophrenia, as our roadmap. Specifically, we're going to focus on chapters 4, 5, and 6 to really understand how this illness unfolds, what the physical evidence in the brain actually looks like, and the ongoing search for its cause.
So, to really wrap our heads around this, we've got to start with the big question that kind of frames everything else we're going to talk about. How does a disease like schizophrenia actually play out over a person's entire life?
Okay, so our first stop is that journey. We're drawing this straight from chapter 4 of the book. We're going to look at the patterns, the when, the how, and what typically happens as someone lives with this condition over many years.
Now, what's so fascinating here is that you can almost map out a typical life course. You might see some really subtle signs in childhood, but the illness usually, well, it really makes itself known during that big life transition, the late teens and early 20s. But here's the thing. The path from that point on is not one size fits all. 10 years later, you see a huge variety in how people are doing. And if you fast forward 30 years, the long-term journey is even more diverse. It's a whole spectrum.
And here's a really critical clue that scientists have latched onto: the differences between men and women. For men, the illness tends to show up earlier, and in a lot of cases, it follows a tougher path. But for women, it typically starts later, maybe in their 20s or even early 30s, and the outcome is often, not always, but often, better. Now, this isn't just some random fact. It's a vital piece of the puzzle. So we've seen the timeline, right? The journey from the outside. But that just begs the question, what is actually going on inside the brain to cause all of this? And that question really pivots us from just looking at the symptoms to digging for the source. And that leads us right into the second part of our investigation. We're basically following the scientific detectives right into the brain itself. We're going to look at the hard evidence that researchers have been finding, all based on the details in Chapter 5. So this is probably the single most important thing to get straight, and Dr. Torrey says it so clearly. Modern science is pretty much all on the same page here. Schizophrenia is a disease of the brain, period. It's not a character flaw, it's not the result of bad parenting, it is a biological, medical condition. And that understanding is the foundation for all the research that matters. And when scientists actually look at the brain, they find real, consistent physical evidence. This isn't just theory, it's what they can see. Those fluid-filled spaces in the middle of the brain, the cerebral ventricles, they're often bigger. You can find measurable changes in the amount of brain tissue, plus differences in the actual brain cells and how they're wired together. Even the brain's energy use, its metabolism, shows clear differences. Now, these changes aren't just random. Researchers have been able to zero in on specific neighborhoods in the brain that seem to be most affected. We're talking about the temporal lobes, which handle things like memory and hearing, the frontal lobes, which are like our command center for planning and personality, and even the cerebellum, which helps coordinate movement. All of these are key areas under the microscope. Seeing what is changing is huge, of course, but it just naturally leads to the million-dollar question, right? The mystery at the very heart of all this research. Why? Why are these changes happening in the first place? What's the trigger? What's the cause? And that why brings us to the final act of this explainer, drawing from Chapter 6. It's time to investigate the suspects. We're going to lay out the major scientific theories that are trying to explain where all these brain changes come from. Okay, think of this as the police lineup of all the prime suspects. First up, the genetic theory. This one's strong. We absolutely know the illness runs in families. Then you have the developmental theory, which suggests something went wrong while the brain was forming, maybe even before birth. The infectious or immune theory is another big one. Could a virus or the body's own immune system be a trigger? Then there's the classic neurochemical theory, the one you've probably heard of, focusing on brain chemicals like dopamine. And finally, stress. Now, stress isn't seen as the root cause, but it can definitely be the thing that flips the switch on symptoms in someone who's already vulnerable. The real answer? It's probably a mix of these. And honestly, this quote from Dr. Torrey just hits the nail on the head. It powerfully shuts down all those old, harmful theories that used to blame families. Instead, it points us right to where the science is today. It's some complex mix of our genes and our environment. So let's just take a step back for a second. We've looked at the journey, the evidence in the brain, and the main suspects. So what does it all mean when we start to put these puzzle pieces together? I think the biggest thing to take away from all this is that finding the cause of schizophrenia isn't about finding a single smoking gun. It's so much more like a complex detective story. You've got clues from genetics, you have suspects in the environment, and you have the physical evidence in the brain. The real challenge is figuring out how all those pieces connect to tell the whole story.
Look, the final page of this mystery hasn't been written yet. We're not there. But the story here is one of relentless, incredible progress. Every single piece of research, every new clue, gets science one step closer to a full understanding. And with that understanding, well, that's where the real hope for better treatments, and maybe one day even a cure, comes from.